Hi, good evening, good morning, everyone. We will start in a couple of minutes, so please stay tuned. Okay, thank you very much. Let's get started. So before we start, let us have a recap of what we have done yesterday, and then we will move ahead with the new services. Hmm? So yesterday we looked at various other features of GCP, and we covered sorry yeah, so we covered various other services. For example, we have seen what is uh, cloud storage. We have seen the relational database from engine from GCP. Then we have looked at various other services along with that. Hmm. And today, now we are going to move ahead with a few more services. One of the key service which we are going to see is the GKE, which is the Google Kubernetes engine, which is a kind of a containerized solution, and we will see that as well. Hmm. Okay, so let us get started. Hmm. We will start with the managed service offering, and this is basically again covers what we have already seen. We have seen what are the different service offerings, service models which are there in the cloud space, and we have already seen what is infrastructure as a service, what is platform as a service, and we have already seen the software as a service. Hmm. So in GCP, we also call one of the service as function of the service, and then something as container as a service as well. We will also touch base upon the serverless concept, and we'll look at what is serverless and how it is going to affect your overall design of your cloud offering. Hmm. So let us go and look at this. Hmm. So as we have seen earlier, just a refresher, this is in infrastructure as a service. In this, what will happen is you are going to take care of the application, the operating system, and any runtime which is needed for your application to work. As a cloud service provider, the virtualization layer, the infrastructure, and the hardware, the servers, everything is taken care by your service provider, where this is the infrastructure as a service. Then we move to the platform as a service. In this case, what is happening is you as a platform or you as a cloud service provider is going to provide all the necessary thing for your application to run. For example, you also provide operating system and application runtime. All you have to do is to bring your application to to this platform as a service and start using it. Hmm? So this is in this case more control is with the cloud service provider. You have to do the customization of your application, and that's it. Hmm? So configuration is your responsibility. Application code is your responsibility. Now within this platform as a service, you will also hear certain other services like container as a service, where you want to run your application in a containerized environment, and you can also use functions instead of apps. So functions are nothing but they are short-lived kind of a codes which will run in response to certain triggers or event. That is function as a service. So GCP function is one of the service which is used as a function of the service. Hmm, Fine. Then we will look at another concept which is called as microservice. This is very unique architecture and very highly utilized nowadays, and this is where everybody is trying to move it. Hmm. So let us take an example. Here is, suppose you have a application. You have an application which has which is a huge application and which has various sections in it. For example, something like this. Uh, yeah, here is your UI, front end UI part, UI UX. Then this is your web server, which is going to be on that server. And then this is your the application logic, and then you also have a backend. So all the code which is needed for your application is part of this big code. Yeah, this is your backend. Yeah. So this is how your typical application will look like. Everything is packed into a single file, which is called as monolithic. Monolithic. Yeah. This kind of architecture where you have all components built as a single code, then that is called as monolithic architecture. Hmm? In this case, what are the challenges? First of all, the first challenge is you have to compile, you have to compile complete code to to add any changes. Yeah, so you have to compile complete code, and then suppose if something breaks in that code, then your complete software is down. Suppose there's some breakage in this, then your complete software is down. Okay, every time you need to do this process, change any component, you have to uh, run a long lasting process. This is going to take a long process as compared to anything else. Okay, so these are the inherent challenges which are there as part of a monolithic architecture. Now, to to improve and to provide more flexibility, the microservice architecture was came into picture. This is so in this microservice architecture, what you are doing is You are breaking your services, breaking your software code into different components. Like booking service is different, customer service is different, yeah? then then your movie service is different, and so on. Hmm? So this is how you will break your a big monolithic software into modules. Hmm? With microservice, you can do modularization of your application and break those into smaller pieces, so that if you want to make a change, only that piece of software will be changed, rest of them will not change. Whenever you want to compile the software, not the complete software will be compiled, you will compile only the that particular piece of software, and everything will work as fine. So by doing this, okay, you are giving more control, you are giving more independence to the components which are, or the module which are part of your architecture. This module can work independently, and then if there is any kind of a need for this module to talk to any other, yes, those dependencies can be sorted out. Hmm? So that's why lot of enterprise are heading towards the microservice architecture, which is focused on building microservices, modularized services, so that you get flexibility to innovate, flexibility to build application, flexibility to change the things. You can also use different languages to build different modules. That is also possible. Okay. One thing to remember, yeah, the deployment and the management of it might be the management that might be also little complex. Hmm? So, okay, so this is the microservice architecture. Now, whenever you look at a microservice architecture, it is generally supported by something called as container. Hmm? So let us go and look at container. See? So we will look at something called as Docker container. Now, what is Docker? Docker is a kind of a type of a container, which is where a microservice container, which is going to help you to spin your applications, to spin your uh, the the features you want to build onto your into your environment. That can be done by a Docker container. Now, Docker container is just like your virtual machine, but it is a very light kind of a virtual machine. It is very light. Okay, that means if you need, let's say, 30 GB of disk for your virtual machine, virtual machine, then for this you might not need, yeah, you might need just 1 GB. Okay, that's the space you earn it. So how it is done? It is done by using something called as a Docker runtime engine. This Docker runtime engine is going to help you to do that. This is, in this case, what happens is it is this container host and the whatever the infrastructure it is, it contains all the libraries, the binaries which are needed, the kernels which are needed for the operating system to function properly. These containers, what happens is they will only have the binaries and the libraries which are needed for that particular application, piece of application to run properly. So this is the concept of container. The container will consist of various layers if you look at the Docker, and this is based upon something called as Docker image. Hmm? So Docker image will have contain all the application code which is needed for you to run any kind of application. Hmm? Okay, they run the same way as any infrastructure which we can run on your local machine and your data center on your cloud. Docker container, as I told you earlier, they are very lightweight, and that's the reason they will be able to spin up down very fast. Hmm? Okay, so in this case, yeah, if you want to compare it to virtual machine, they do not have a guest OS, yeah, but they have something called as a runtime support engine, which will help them to run and function properly. With this container, you also get isolation, because yes, all this container has their own life cycle and they can run independently of each other. All these containers. Hmm? Okay. And then again, your Docker is cloud neutral. I can run the same Docker onto a AWS container. I can run the same into Azure and so on. Hmm? So this is your Docker container. Then To manage those Docker container, we need some kind of application, some kind of a tool which will help us to manage all those things. Now that tool is called as container orchestration tool. Hmm? So there are variety of container orchestration tool. We will see that. Okay, suppose I want to have 10 instance of microservice. Okay, A container, 15 instance of B container. Then what I'm going to do, I'm going to look at some of the typical features like auto scaling, any kind of a service discovery, yeah, any kind of a load balancing of the traffic, self filling, and even would like to have a zero downtime. So all these features will be available with your microservice kind of a architecture. So you can scale container based upon demand. Whenever there is a high demand, you scale up. When there is no demand, you can scale down. Hmm. Then it has to have a self-healing mechanism wherein you can do a health check and replace any kind of a, a container which is not performing good. Then service discovery, it is one of the very important part. So your microservice should be able to work with any other microservices, find it, work with it, and then continue to live with it. Okay, so this is the service discovery. And again, whenever I want to release a new software or new version of my application, then yeah, I should have some provisioning so that I can have a almost zero downtime for the deployment of the new version. Okay, so these are the few of the things which um, we will look at. So fine. So we will look at how these things can be done within the GCP environment. Now we will go to another concept which is called as serverless. Now, as the name suggests, it should not have any servers, correct? No server. But is it possible to have no servers and then still be able to support it? Yeah, if you look at a logical answer, yes, it is possible. But in physical sense, there will be some server, there will be some kind of an application layer which will help you to make this whatever the storage which is there which will not be transparent to you, and you will be working independently of the underlying hardware. So this concept is called as serverless. Okay, wherein you don't have to worry about the servers, the OS, nothing. Yeah, you don't have to worry about it. All you have to do is to bring your code to this service and start working with it. Okay, so with serverless, what you get a peace of mind in terms of no infrastructure to be mapped, no patching to be done, no updates to be done, nothing. It is taken care by your service provider. And then whatever the serverless components we are going to use, they are again also a pay as you go model. Hmm. So another concept which is very important when we are trying to use the serverless architecture is that you focus on your code, and then the cloud service provider will take care of all what is needed for your code to work properly, your code to provide a low latency to the application, and it should be able to support millions of requests. Hmm? And then how how do you pay for the serverless architecture or servers? uh, you pay for number of requests which comes, yeah, the amount of duration the request has been handled, and so on. So like this. So okay, so we will not look at more of this because yeah, this is what I have already covered. So let us look at few of the services which are available in GCP, or which are the managed services. So one of them is compute engine. We have already seen that it is going to provide you high performance, yeah, and general purpose virtual machine that can scale globally. Now this will fall under the infrastructure as a service category. Then you have another service which is called as Google Kubernetes engine. Yeah, this is nothing but a orchestration tool for your microservices which are built on the open source Kubernetes platform. Hmm. You need advanced cluster configuration and monitor for this to work with it. Then we have app engines. It is a highly scalable application which is fully managed using open and a lot of tools, language tools, which you are familiar with. So you write the code in your own language, be it Java, be it C, bring it to the app engine. bring yeah, and then it will take care of the necessary infrastructure which is needed for you to start working it. Then we have cloud functions. Cloud functions are nothing but, I told you, they are the small snippets of codes which will run in case it is triggered by any kind of a threshold or any kind of a event. So it is built, it is a, again, it's a event driven application which is very very easy to work. Then cloud run, you can deploy and develop highly scalable customized container application, and for this you don't need something called as cluster. Okay. So fine, this is your the managed service offering. Okay, so fine, let us go to GKE. So we have already seen this, we will move to the GKE. Yes. Okay, so what is GKE? GKE is nothing but Google Kubernetes Engine. So to give a background, okay, so Google has started with a project for this kind of a containerization of their application and working on the microservice architecture somewhere in the year 2014, and they started with this project which is Kubernetes. Yeah? And eventually they started involving other people to contribute in the code of the source code of the Kubernetes engine. And that's how the open source Kubernetes came into existence. Now because it was handled by more by Google, they what they did was actually, because then there would be like the ownership which will come to Google and all those things. What they did is they have donated this Kubernetes complete engine, complete solution to a open source community. Okay, and then what happens is this open source community, or the open source community is nothing but you and me. Yeah, so there are normal users like you and me who are contributing to the code, changing any features, changing any functionality, and improving the performance of the particular application. So they have donated this to the open source community, and now it is being monitored by the CNCF community, which take care of any kind of new features, new functionality which is added onto the Kubernetes engine. Now the Google flavor of the Kubernetes engine is nothing but your GKE. So this Kubernetes engine is going to provide you the orchestration facility for your container within the Google platform. Yeah, so let us go and look at this. Yeah, so we have already seen this, but yes, so open source container orchestration solution. When you create a Kubernetes environment, you create something called as cluster. So this Kubernetes will also provide you tools to manage the cluster. Yeah? And you can have different types of virtual machines in this particular cluster. Hmm? Then it provides various other important orchestration features like service discovery, auto scaling, load balancing, self-healing, zero time deployment, and so on. So these are few of the characteristics you will look for any container orchestration tool and work with it. Hmm? Fine. So again, remember one thing: this is a open source, and this is the managed Kubernetes service from the GCP. Hmm? So here it is. It helps you to minimize your operation with the auto repair or repair failed nodes and auto upgrade features which are available with your GKE. Yeah, it provides the concept of pod and cluster autoscaler, which will help you to increase the capacity of your nodes. Hmm? You can also enable cloud logging, cloud monitoring with a simple configuration for this GKE. Then you can also use container optimized OS or hardened OS, which are built by your Google or yeah, maybe other service provider as well. Hmm? It provides support for persistent disk and local SSD as well. So that support is also available. Okay. So yeah. So any questions until now before I move to the next? Huh? Okay, nothing. Fine. That's okay. Let us move ahead. Yeah. So this is kind of a exercise which we can do. Yeah, but in interest of the time, we will not do that. But if you, yes, if you need more details on it, I can just share you a link of it. Here it is a link. Yes, here it is. I will switch my account. Let it be. Yeah, and yeah. Okay, so with this microservice architecture which is running on your Kubernetes engine, you can install a Kubernetes application, create a microservice, and then play with it. Okay, and by doing this, what you are going to do is you can what you can say is um, you create Kubernetes cluster to run the container engine containers within the Kubernetes environment. Then for that you need to create a cluster, and there are various way to clear a cluster. You can do it via CLI, you can do it via console, and so on. So these are the few of the command which you can try it out if you want to build a Kubernetes engine onto your. Yeah, fine. Then we will not look at all those things because yeah, this is part of a complete exercise. We will not going to do this exercise. And whenever you want to build a application or build a machine in GCP, then what you can do that in a declarative way like this. You can just mention what is going to be needed, what is the namespace, how many replica set you are going to have, and the namespace. Yeah, like this one. Hmm, yeah. Okay, so you can write a file like this. This file is called as manifest file. Oh, yeah, or people will sometime call as a YAML deployment file or YAML file simply. In this case, what you can see, there are different components here. You have to have a API version, then the kind, the metadata, and so on. Then the spec will contain all the details about whatever the machine you have created or the API you are going to use, and so on. So you can do that by using a deployment YAML. Yeah, another version, another it is saying service, and so on. Okay, so this is what microservice is all about. Yeah, and if you need to know more about the Kubernetes, there is lots of actually um, tutorials and documentation which are available on the internet. Yeah, I want to just go and show you kubernetes.io. This is the website of kubernetes.io, and you go here and you can just try it out. You can set up your Kubernetes engine. Yeah, how to install on Mac, how to install on Windows, and so on. Yeah, and then there are certain utilities you need to use. There is a utility called kubectl, which is needed for you to work with your Kubernetes engine. Okay, fine. Uh, yeah. So whenever you want to work with your Kubernetes engine, you can also have an option to create a cluster. Cluster is nothing but a group of your individual EC2 instance. And if you look at the architecture of or the architecture of the Kubernetes, then it works on something called as a master node and a worker. And that is being build install on the same cluster. Hmm. So what the master node does it like yeah, it has certain components like API server, kube scheduler, a control manager, and then the etcd, which is nothing but um, a key value store database where it stores all the information about yeah, all the information about your Kubernetes engine. What is the state of the particular pod? Yeah, whether it is started, whether it is stop, or it is terminated. All those things is available there. Hmm. In the etcd. Then, like this, we also have something called as worker node. Yeah, and then what is worker node? The worker nodes are the one which are actually doing the execution of the things which is passed by your master node. So in this diagram, you can see we have a master node which is 8. Yeah, this is 8 machine, and here also you have a 8 machine. Yeah, once they are able to work with it, yeah, and so on. Hmm. So so like this, you will have one master node and one have a the worker node. Master node will take care of all the communication, controlling everything of all the worker nodes within the ecosystem. And worker node are nothing but the actual executor of the things which we have just passed to them. So this is your GCP. Um, yeah, GCP Kubernetes engine. Hmm? So worker node, its component is it can run on your pods, and for working with this your worker node, you need to use a utility called kubectl or kubelet. Okay, every vendor will have their own way of calling them and using different tools for it. Okay, so this is, yeah. Before we jump onto that, I just want to show you architecture, Kubernetes concept, task tutorial, cluster architecture. Yeah, and cluster architecture. Where is this showing? Okay, controller. No, I'm looking for a complete diagram actually. Create. Uh, um, where is the diagram? Architecture diagram. Let me find out. Yes, this is a better architecture diagram. Yeah, so you can see this is how the Kubernetes architecture will look like. You have a master node, and then you have a the worker node. Master node has this components, which is API, scheduler, controller, okay, and etcd, which is the key value pair database, and that talks to this API server. It is his work is only to to connect with the worker node, use the APIs and talk to them, yeah, and get the details. Now this API server is already also integrated with your other component, which is scheduler, controller, and the etcd. And whenever there is any change, the API server will tell the etcd to maintain the state, to have a detail about that state, and then the controller and the scheduler will be able to put the pod in the particular node. Hmm? So this is how the architecture will look like. etcd will have the state of all the resources within your cluster, and if it fails, then there's a problem, yeah, in your Kubernetes cluster. Okay. Yes. So let us look at what are the different types of cluster offering we have a zonal cluster, which is divided into a single zone and a multi-zone. So single zone will have a single control plane, and node can run in the same zone. But with multi-region, you can have a single control plane with, yeah, but no codes will be running in the multiple zone. Then yeah, region cluster, it is nothing but a replication of control plane which is run into multiple zones for a given region. Node also runs in the same region as where the plane users. Yeah, correct. Then you can also create a private cluster, which you optimized for your virtual private network. The nodes only have the internal IP address, and that's it. Hmm? Then we also have another kind of a cluster which is called as alpha cluster. Yeah, cluster with alpha APIs. Yeah, they are used to test your any new Kubernetes feature. Hmm? So these are the different types of the cluster which are available within your GKC. Okay, so let us go and understand how the Kubernetes look like. Okay, so in the Kubernetes, the smallest unit of any resource is called as pod. Yeah, this is the smallest deployable unit of in the Kubernetes. A pod can container one or more. A pod can contain one or more container. Yeah, so this is again whatever the container we talked about. The container is going to set into this, and then it will be used. So each pod is assigned a ephemeral IP address. Yeah, whenever the yeah, so whenever we want to onboard, yes, at that time we can have particular IP assigned, but yes, for this we ephemeral yeah, so we will have a ephemeral IP address. All container in a pod, whatever the containers which are there in the particular pod, will share the same storage, network, IP address, port, and even the volumes. Hmm? The pod can be in different stages: running, pending, succeed, failed, and unknown. So this is the pod file. So here it is. If you can see container here, one, this is one pod, this is second, yeah, and this is third. Okay, fine. Then look at the what is deployment and the replication. Okay, so deployment is nothing but it is kind of a blueprint of your microservice, how the each of the microservice are going to be created. Hmm? So whatever you are going to do it via your deployment, it represents the microservice which you are trying to target. Hmm? You can have a kind of a release management, you can have a source code management, all those things can be added to this layer. Then if you go to the inside, you have something called as replica set. Replica set is similar to the auto scaling group. And what it does, it ensures that a specific number of pods are running for a specific microservice version. Hmm? So this is how do you kind of um, investigate any kind of a thing which will arise from any kind of a replica. Then deploy V2 of a microservices, create a new role, set the permissions, yeah, and then update whatever the red replicas we have, all those things, and then check out whether the new version of the software is working properly or not. Hmm? So any questions on this? Yes, no? I'm expecting a lot of questions on this, but yes, nobody is asking anything. Fine. Okay, let us go to the other part. So when we are trying to use your Kubernetes, we have to work with various services. Now there are different services based upon what we do within our environment. Okay, so each pod will have its own unique IP address. Okay, this will ensure that any end users, yeah, who are external will not be able to impact. Okay, the pod fails and is replaced by a replica set. That is how we are going to take care of it. Create such cluster, create service. Whenever you want to create a new service, for example load balancer, then you can use this. And then the type of cluster. Okay, so you have a clustered IP which will expose your on-premise or a cluster internal IP address. And in this case, yeah, if you want a microservice only to be available inside a customer, then yes, you can do that with the cluster IP address. Then we have a load balancing. A load balance. What it does, it yeah, you distribute the application traffic to several services. Yeah, yeah, and then you can say yeah. So you can create a load balancer. You can add various services which will take care of the load balancing. Node port is nothing but it's a service which yeah which expose a node IP address at a static port within the particular node. Hmm? So I hope this is clear. Sorry for that. Yeah. Okay. So whenever you want to work with your Kubernetes engine, each pod will have its own IP address. That is how it is going to communicate with each other. Yeah. So how do you ensure that any external users are not impacted whenever the pod fails or it is replaced by any other different pods by using a service called as replica set. Okay. So yeah, or a new release happens and all existing pods of old release need to be replaced with the new. So for this, you can create certain services. Yeah, you can use, yeah, you can expose the pod to the outside world using certain IP address, and then that can be done on the certain port number. So there are three types of services you can expose, which you can, yeah, you can have a cluster IP, you can have a load balancer, and then a node port. So cluster IP, it is nothing but it is going to expose your service on the internal IP address. Suppose you want your microservice to be available only inside of your cluster, then yes, it can be done that. Yeah. Suppose if you want to expose your service outside of your environment, then you can go for a load balancer kind of a service, which will help you to give the external connectivity. And then each service on each node's IP address will work on a particular port, which is called as node port, and it will be a static port. Okay. These are the different services, yeah, you can use. Then let's go next. Yeah. Okay. So now another very important concept is called as container registry, or you can also term it as a image repository. So whenever you want to work with your container, you need to start with a Docker image. Hmm? This Docker image will have all the required things which are needed for your application to work. For example, if you want to add just a Apache web server, then you will have a container for a Apache web server. So all these images need to be stored somewhere, and that storing location is called as registry. Okay, you can call it as a container registry or a image registry. Hmm? So the container registry will have a fully managed container registry, which is provided by your GCP. Okay, this is similar to other publicly available registries. For example, Docker Hub. So Docker, which is provided, okay, the Docker container which is provided by a company called Docker, also have a registry for storing the images, and that is called as Docker Hub. Hmm. So you can use this Docker Hub to store, or the container registry to store the images which are needed for your container to work properly. All these things can be integrated into a DevOps or a CI/CD tool, which will help you to publish these images to the registry. And this is can be automated by using the CI/CD tool. You can also have some kind of a security measures to control the access, to control the security of your container images. You can have some kind of a policies which will help us to enforce some kind of a uh, vulnerabilities and deployment policies as part of it. Hmm. So the naming convention will be something like this: host name, project ID, image, and the tag. So like this. Yeah, the host name is gcr.io. Then the project name is this. What is cluster of container in Kubernetes? Okay, if you look at the, yeah, so uh, whenever you want to create a environment within your Kubernetes, you create a cluster. That cluster consists of two components. One is called as a pod and one is called as node. Now node, you can have an analogous representation of a node as a virtual machine, EC2 virtual machine. And when I call a pod, then what I do, I divide this particular virtual machine into very small uh, containers, which is called as pod. So if I think if you are looking for an answer that yes, what is a node, then yes, this is the node. This is the answer for your question, Navid. Hmm. So you can, yeah. So this is how you are going to save the registry. Hmm. Okay, so few things to remember as part of your so okay, whenever you want to replicate your master node, you can do it across multiple zones for high availability. That way you are going to get a availability. Some CPUs on the node is reserved by the control plane. Yeah, for example, first core 6%, second core 1%, third and fourth point. Yeah, so remember that yes, certain capacity is reserved and which cannot be used. Okay, so creating Docker images for your microservice, this can be done by using something called as Docker file. In the Docker file, you defined what is the base image. For example, if you want to create a Ubuntu machine, then you define the base image and then you run some packages and so on and then create. You do a port binding as well like this. Okay, and then create that customized image and then push it to your container registry. Okay, like this. Okay, so this is also, yeah. Then then you can do a lot of deployments on your Kubernetes environment. You can build any application, you can host any services on this Kubernetes engine. Now your Kubernetes supports a stateful deployment. Okay, stateful deployment which is supported by various services like Redis, Zookeeper, Kafka, and so on. Then a setup pod which has a unique persistent identity and a stable host name is also called a stateful state set. Okay, that is also one of the concepts. So how do you run services on node for log collection or monitoring? You do that by using something called as daemon set. Okay, one pod on every node. Yeah, you will see that you have a daemon set which will talk to your the control plane and then take care of it. Hmm? All your whatever the components, for example your virtual machine, your GKE environment, all this can be okay monitored by using services like cloud monitoring or cloud logging. Yeah, so cloud logging system, and application log can be exported to BigQuery or also to a service called as PubSub. Hmm? So we'll see PubSub what is there. But yes, you can store the logs, whatever it is there, into a database, or you can also send it to a queue for further processing. Okay, so let us go and look at few of the commands. So this is like if you want to create a cluster, this is the command. If you want to resize, this is the command. So resize, create. And if you want to update the cluster size like this, which is having a max and min, max is 10, min is 1, then yes. If you want to delete, this is the way. If you want to add new, so this is a very vast topic actually. So which will not be able to cover in this short period, but yes, let me just go and share you that GKE. GKE. Yes, here it is. You can just go into the features, yeah, and various things. You can look at all the features. Okay. Yes, all the features are listed here. We can just go some of the key features which are there, like pod and cluster auto scaling. This is one of the, yeah. Okay, then you can have a pre-built Kubernetes application and template which can be used. Then you have a native networking and security for your the containers, that is also there. Yeah, and you can also migrate a traditional workload to the GKE container with ease. You can use services which are available with the various service provider. Okay, so let me share this link. Now, that. Okay, let me share it with everyone. Here it is. Okay, fine. Let us move ahead. So we'll not look at much of the command. Yeah. So these are very, there are a lot of many commands. This is not this the single one, but yeah, there are so many things. Okay. Now let us go and look at some of the scenarios. So suppose you want to keep your cost low and optimize your GKA implementation. What you can do? Yeah. Consider preemptible virtual machines. Yeah. This is one of the very useful options. Okay. Use a right region if needed. If you are seeing that your application is going to need a sustained usage, then go for a committed kind of a purchasing. Okay, each machine types are cheaper than the EC2 machine are cheaper. E2 machine types are cheaper than the N1. Yeah, so remember that. Choose right environment to fit your workload and the type of it. Then you want an efficient, completely auto scaling GKE solution. So this is can be done by using a horizontal pod autoscaler, which can be used within your development or your node tool as well. Yeah, suppose you want to execute the high the untrusted third party code in Kubernetes cluster. Okay, so you can create a new node pool with the GKS sandbox, deploy this code, test it out, and then shut down your sandbox. So this is the way you can do a testing. Then my pod stays pending. Most probably pod cannot be scheduled onto a node. Pod state waiting. So these are actually the, if you look at this pending and waiting, these are the state wherein if you face some issues with your pods, then it goes into this state and you will not be able to work with it. So you need to just go and look at the various options for fixing it. Okay. Uh, just a minute, what is happening here? Discard. Yeah, and here is my page, and yes. Okay, fine. So now we will move to another service which is called as cloud function, and then we will move to the networking part. Now, as I told you, function as a service. So within the GCP, we also have something called as cloud function. Okay, so this what the cloud function does is you write a code in this cloud function, which will which will solve your problem. For example, let's say you want to start a virtual machine, so you can just write a code in this cloud function. Okay, and then you can have some kind of a logic built into it that yeah, whenever somebody wants to, yeah, somebody maybe just a hypothetical, in a particular account somebody just stop or try to delete a machine. Yes, what you can do, you can just simply start another machine. Okay, this code you can put into your cloud function, and this cloud function will be triggered based upon the cloud monitoring. Yeah, and it will take an action to restore that particular virtual machine. So this is how your cloud function will work. It will work only when it is triggered, and the rest other time it is not going to be working. Okay, whenever you want to use the cloud function, the billing is based upon number of invocation. Now, what is invocation? Invocation is nothing but the usage. So if you use one time, then it is one invocation of your your function. Then uh, the pricing also depends upon the duration for which the invocation happens, and it also depends upon the amount of memory and the CPU you have provisioned for this function. So these are the three ways you are going to get the bill for this. Hmm? Remember one thing, this Azure function is actually very time bound. So any function or any code which is not going to last more than 9 minutes, okay, then this is the right fit. If your code is lasting more than 9 minutes, then this is not the right choice. Either you break that functionality into different components or you use the virtual machine. Hmm? The function. Okay, some of the concept within this, the event. What is event? It is nothing but a object upload to a cloud storage. So this can be event, and then trigger can be response to an event with a function call. Okay, and then what is trigger? Which function to trigger when an event happens? So you have to define that. The function takes the event data and then performs the required action. So this is very similar to the Azure function as well as the AWS Lambda. Events are triggered from your cloud storage, PubSub, yeah, Firebase, Firestore, Track driver logging, and all the other various API methods. Yeah, so you can write a code like this and so on. This is just a simple hello world code. Okay. So, few things to remember when we are using a Azure function. Azure function is nothing but a kind of a serverless service where you don't have to worry about the server. Okay, you don't need to worry about the scaling, the availability, and so on. It is taken care by the cloud provider. Yeah, the cloud functions automatically spins up and backs down in response to a event. So they can add more capacity and so on. Yeah, cloud functions are recommended for speeding for responding to event such as, yeah, maybe any kind of a long running process or any, yeah, what you can say, a time bound application which needs a certain application to perform in a certain way. So yes, you need to remember that. Okay, so fine. This is the command which we can run mm, on your container, and so on. Will not see that. So now we will directly move to the first to the VPC section. Where is my VPC section? Okay, it is at the end actually. Just a minute. Any questions? If you have, just post it in the chat. Okay. Yeah. Okay. That is the data warehousing solution. Okay, I need VPC. Yes. Okay. Now let us go to the networking part. Okay. So we have seen the networking in other components, yeah, other service providers. There are certain concepts like CIDR block, public IP address, private IP address. I will not go into this, yeah, but I just want to understand that whenever you want to create your own private network, you want to create your own private network in GCP, then you have to create something called as virtual private cloud or VPC. Hmm? Now, in terms of GCP, yeah, this VPC has a very unique, yeah, thing which is not which is something different from the other service provider. So whenever you want to create your own isolated cloud or a network within the cloud, then you need to go for a yeah, VPC. You can control whatever the traffic which is coming into your VPC or whatever the control traffic which is going to outside of your VPC. Okay, yeah. Then whatever the resources you are creating within your environment, they all will be created within a VPC. Okay, and VPC will be highly secure. It will have secure resources from yeah, will secure from any unauthorized access, and it will enable secure communication between your application and the cloud resources. Hmm. So VPC is a global resource and can contain subnet in one or more regions. So this is very unique. If you look at AWS, if you look at Azure, the subnet has to live within the VPC. But in this case, it is not the case. Your subnet can live in another region or in another region. Hmm. So remember, this is not tied up to a region or a zone. VPC resources can be in any region or a zone. Okay. Now, then what is the need for a VPC subnet? Okay, so there can be different types of application, different types of resources. For example, database. Okay, so each type of resource has its own access. For example, if you have a web server, the web server can be accessed by anybody and it can be exposed to the internet. But when it comes to your load balancer, sorry, when it comes to your database, then you need to have a private connectivity. So in that case, yes, you want to keep that into a private subnets and so on. Okay. So if you want to have kind of a segregation of your subnets, segregation of your resources, then you should go for something called as subnet. Yeah. And if you need the resources which are public, in nature, they can be in the public subnet, and the other resources they can be in the private resources. Hmm. So yeah. So how do you create a subnet? Okay, so whenever you want to create a subnet, yeah, you just create that particular subnet in your VPC, and then the public subnet can be accessed via internet. Whatever the resources which are there part of the private subnet, they cannot be accessed via the from the internet. But resources in a public subnet can talk to resources in the private subnet, because yeah, they are part of that particular VPC. And that's the reason they are able to talk to each other. Each subnet is created in a region, and so on. Okay. Then yeah, by default, every project will have a default VPC. Okay, you can create your own VPCs. There are two options. One is the auto mode VPC creation and the custom mode. Custom mode, you will give all the options what is needed for you to work with it. Okay, but when you use auto mode, everything is provisioned from you, right? From the subnet, yeah, and the network tags and all those things are taken care of. Okay. Yeah, when you create a subnet, you should enable something like private Google access, which will allow the VM to connect to the Google API using the private API address. Also, enable a flow log to troubleshoot any VPC related network issue which might arise because of this case. Okay, so this is, yeah, subnet. So we have seen this. Okay, we have already seen what is CIDR, so we'll not go into it. And yeah, so very important, firewall rules. Firewall rules are kind of a, I would say, uh, it's kind of a security rules or security or the security group within the GCP. Yeah, they control what kind of traffic can go in or outside of your network. Okay, and they are stateful. So each, yeah, they are stateful. That means if you enable the rule on inbound port, that particular for that particular port, then same is allowed on the same is allowed uh, outside communication as well on the same port. That's why they are stateful. Then each firewall rules, whatever we have going to create in this, yeah, in your firewall, they will have a priority. Yeah, they will have a priority which is assigned from 0 to 65,000, 3,500. Yeah. Okay. The lower the number, the higher the priority it is. So if you have a priority of 65,000, then it is going to have a lowest priority. A default implied rule with the lowest priority are, okay, now this is the default rule which is there in all the firewall rule. Allow all egress. That means any outside traffic which wants to go to outside world, allow it. But deny any traffic which is coming from the outside world. Yeah, why? Because you don't want anybody to go and completely reach to your environment and then hack it. Okay. Then third important point is default rules can't be deleted. Okay, you can override default rule by defining new rules and which can be in the priority. So it's a very simple. You cannot deny any what you can say default rules. Fine. Then default VPC has 4 different rules with a priority of 65,034. Yeah, those are like any incoming traffic coming from a VM instance is in the same is by default allowed. Any traffic which is coming on port 22 and on port 339 is also allowed. Okay, this is a default behavior. Any incoming ICMP for any source on the network will be allowed. Okay, so ICMP is nothing but your ping protocol. That is also allowed. This is also very unique. By default, it is not there in the other service provider. You have to go tick it and then use it. Hmm. So yeah, what are ingress and egress rule? We'll see that now. What's happening? Okay, it's ingress rule. Just a minute. Yes, network rule. is the VPC section? Here it is. Yeah. Okay. Yes. Fine. It's not happening. Okay. Fine. No worries. So let us look at more details about any incoming traffic which is coming from outside to your GCP target. Yeah, that is nothing but your ingress route. Okay, all instance with a tag. Yeah, SA. Yeah, they will be helpful for you to define that this is the destination. Any source, okay, which defines where the traffic is coming from. They can be any CIDR block, they can be any instance or any instance with the any kind of a tag or so. Then you also have ingress rules. Ingress rules is for outgoing traffic to a destination from your GCP target. Okay, so target can be all instance or instance with a tag. Destination can be any CIDR role. Okay. Along with each role, you can also define what is the priority. The lower the number, the higher the priority. The action you want to take, which is allow or deny, and then the various protocol which is going to be used with a particular service. Hmm? You also need to specify the port on which it is going to work. And then there's another feature which is very unique, which is the enforcement status, whether it is enabled or it is disabled. Hmm. Let us look at some of the scenarios of shared VPC, and then we'll move to the other part. Okay, suppose you have your organization have multiple projects, and you want to have a resources in different project to talk to each other. So how do you do that? How do you allow to talk to each other? You can do that by using a concept of shared VPC. What do you do is you create an organization or a shared folder level access. Okay, and then allow networks to be shared between your project in the same organization. Same shared VPC contain one host project and multiple service object. So like this, host project is the contains shared VPC, and the service project contains the host project. Okay. By using this, you will help to achieve kind of a separation of your concern, like network administration is responsible for a particular project, resource users are for a particular project, and so on. Okay, so it is also taking care of the separation of the concerns by the customer. Then look at the concept of a VPC peering. So now, whatever we have talked about a single VPC. Yeah. Now, then suppose there are multiple VPCs. Yeah, this is one, and this is one. So what will happen if I want to talk from this VPC? Yeah, from this VPC to another. Okay, how do you do that? Okay, if I want to talk from this to here, how do I do that? Okay, and from here to here. So this can be done by something called as VPC peering. What a VPC peering does, it helps you to connect your network one VPC to another VPC. Okay, network in the same project, different project, across project in a different organization can be peered by using something called as VPC peering. Okay, all communication will be happening using the internal IP address. That is the beauty of the VPC peering. Why? Because your traffic is never leaving your environment. Hmm. Highly secure because not accessible from the internet. There's no data transfer charges or for data transfer beyond between the services as well. Then remember that network administrator is not change. Admin of the one of the PCC do not get the role automatically in a peered network. It's fine. So that's it. Do you have any question from the networking side before we move to the hybrid cloud? No? Yes? Let us take a pause of 5 minutes and we'll come back. Let's take a 5-minute break. I'll be on mute. Okay, thank you. I'm back. Let's get started. So we were talking about the peering. Yeah, suppose when we want to communicate between the VPCs, how do you communicate? We use something called as VPC peering, and then VPC peering allows us to use the internal network of the GCP to talk to each other. Yeah, and this will what it will do is it will it will simply use the internal network to do the communication. That way it will be highly secure. Hmm? So yeah, so network in the same project, different project, and across a project, when they can be peered, they will be able to communicate to each other via this VPC peering. So there will be no data transfer charges for a data which is being transferred between your services. Yeah. So remember one thing: whenever you transfer your data outside your VPC, that data is charged actually. But since because it is moving from one VPC to another VPC, it is actually not going to be charged when you are going to use a VPC peering. Hmm. Okay, yeah, remember network administration is not changed because of this. You do not admin of VPC do not get the role automatically in a peered network. So you have to go and specifically add the permissions to start working with this. Anybody who's a network administrator of various VPCs, he need to have the right permission to start working with it. Yeah. Then we will go and look at the hybrid network. Now, what is hybrid network? Now, whenever you want to connect your GCP environment to your on-premise environment. So on-premise environment can be your company network, can be your office, and so on. So for this, you need to use something called as Cloud VPN. So this is one of the way you can connect your GCP to your on-premise network. Hmm. This is done by using something called as IPsec VPN tunnel. This is a secured way of connecting, a highly secure way of connecting to your the on-premise environment. Okay, whenever you pass this traffic is routed to the internet through the internet, but it is actually it creates a kind of a literally a tunnel, okay, of a, so yeah, and then traffic is passed through it. So once your traffic enters from one side of the tunnel, then it leaves on the other side of the tunnel. That is how it is. The traffic is encrypted using the encrypted key exchange protocol, IKE. Yeah, that is called as IKE. IKE v2 is the latest one which is used for encrypting the traffic. Hmm? There are two types of VPN tunnel solution. One is called as HAVPN, which uses a BGP routing, which is called as Border Gateway Protocol, which is a dynamic routing protocol which learns all the routes of the nearby networks and then and then do the routing. Okay, so with this HAVPN, you get a SLA of 99.99% and with two external IP address. With this, then you have a classic VPN, which is not going to support the dynamic routing, and it is going to have a static routing wherein you have to define the route. Okay, you have to define the policy and so on. Okay, you can also do a dynamic routing by using the classic VPN. In this case, you are going to get a less SLA and it's just one single IP address, external IP address for you. Then this kind of a cloud VPN. It is good for certain use cases, but in this case, what is happening is your data is moving out of your network, going into the internet via the tunnel, and then onto your on-premise. Now, this is actually leaving the secured boundary of your environment into the internet and then to your environment. At times, this can be a risk for some customer. And the throughput of your network or the throughput of the network speed is also going to be fluctuating and it is not going to be constant. Now, for avoiding such kind of scenarios, you can go for something called as cloud interconnect. What is this? This is going to be a high speed physical connection between your on-premise environment and your VPC network. Okay. So this is on the one side, it is your on-premise, and on the other side is GCP. This is going to provide you highly available, high throughput, consistent bandwidth between your on-premise and your cloud. Hmm? So this will be your dedicated connection wherein you pass the traffic between these two endpoints only, and no other traffic will be passed to it. Okay. So there are two types of connection interconnect, which is possible. One is called as dedicated interconnect, and then there is a partner interconnect. Now, dedicated interconnect is going to give you a throughput of 10 or 100 Gbps, whereas if you need any sub 10 gig kind of a throughput, then you need to go for a partner interconnect. Yeah. Okay. So these are the two ways you can create an interconnect, and this is not going to use the internet, but it's going to use a dedicated connection between your. Data exchange happens through a private network. You communicate using VPC's network internal IP address from on-premise network. Mm. It also reduces your egress cost as a public internet is not used. Okay, there are supported Google APIs and services that can be can be privately accessed from your on-premise as well. So this is also possible with this. Then use, yeah, so this can be used only for any kind of a high bandwidth needs. Okay. Or when you need a consistent throughput, then yes, go for it, because this is not cheap as compared to your cloud VPN. Cloud VPN is very, very cheap, but your cloud internet connect is not that cheap. Hmm. Then direct peering. Okay, this is one of another concept. Yeah. So direct peering, like it connects customer network to Google network using the network peering. It creates a direct path from your on-premise network to your Google services. Okay. And remember, this is not a GCP service. It is just used to lower your network connection outside of your GCP. It is not recommended. Yeah. So you can use cloud interconnect and cloud VPN. Okay. So if you don't need this, then yeah, go for this two services. Okay, so fine. Let us go and look at one more topic, which is uh, yeah, cloud monitoring. We will look at the cloud monitoring. Okay, so whenever you are working with your virtual machine, your services, your databases, all those things, okay, what we are doing is we are continuously trying to gauge the the health, or gauge the understanding that yeah, whether my application is working properly or not. Okay, so if you want to have some parameters, some metrics to monitor that, that can be provided by a service called as cloud monitoring. Okay, so this cloud monitoring will help you to check whether your application is healthy. Okay, if there is any issues which are occurring because of this problem. Okay, whether your storage is properly utilized. Okay, whether it is underutilized, and whether the capacity is properly utilized or not. All these things can be done by using your cloud monitoring. Okay, this is a tool to monitor your infrastructure. It measures key aspect of your services like CPU utilization, disk in, disk out, network throughput, network in, so on. All these key things which are measured by using cloud monitoring are called as metrics. Hmm? This matrix can help you to take certain actions based upon this matrix. For example, we have seen um, the instance group. Yeah. So in that case, we can use CPU utilization as one of the metrics to scale up and scale down the number of instances. Hmm? You can configure alert. Alert can be like based upon your billing alert. Okay. It can be a CPU utilization alert. It can be a machine, virtual machine, which is going down, and so on. So you can do a lot of things. Hmm. So let us look at another. Yeah. Then what is cloud workspace? Okay, so you can use your cloud monitoring to monitor one or more GCP project, or one or more even AWS account. How do you group all this information into a single pane? Okay, so for that you can do, what you can do is you can use a workspace. Okay, the workspace will help you to organize your monitoring information into a single pane of glass, and then you will be able to monitor everything in the single. Yeah. Okay. So that is the use case of your workspace. Hmm. So let us go and look at some of the common metrics which are available for various resources. For example, virtual machine. Hmm. So what are the metrics which are available with your virtual machine as a default metrics? You can look at CPU utilization. You can look at the network traffic. You can look at the uptime configuration and some disk traffic as well. Okay. So this is by default available with your cloud monitoring. Hmm. Suppose if you want more things, for example, you want to have you want to get information for your disk, networks, and then yeah, various other things. Then you can do that by using something called as cloud monitoring agent. Okay, so that will help you to collect the data based upon certain demands. Okay, whatever the metrics which are collected from the VMs are then sent to the cloud monitoring. So this agent will help you to get that thing. So fine. Then we will look at another service which is called as cloud logging. Yeah, just a minute. Okay. So another service which is called as cloud logging. Yes, this is free now. Yeah. Okay. So if you want to have a real time log management and analysis tool, which will help you to search, store, analyze all those data, yeah, then you can go for a cloud logging. Yeah, it is a exabyte scale, fully managed service wherein you can just ingest log data from any source and then do a analysis on it. Okay. So some of the features of this cloud logging is that you can do a sort, search, analysis. Okay, you can also create a visualized dashboard. You can capture metrics from various logs using queries, string parameters, and so on. And you can route different log entries to different destination as well by using the cloud logging. Okay, so how do you do that? Yeah, most GCP managed services automatically send logs to the cloud logging, for example, App Engine, GKE, and all. How do you do that? To ingest log from a virtual machine, you need to use a logging agent, okay, which is based upon one of the um, image which is called as Fluentd. Hmm. You can run this logging agent on all the virtual machines, and then that will be able to pass all the logs to this. To ingest logs from on-premise, you can use something called as bind plane tool from Bloom Modera, okay, which is a tool which is helpful for you to collect the logs from your on-premise as well. Okay, in the backend, what it does it uses the cloud logging API to get the details about it. Hmm. Then auditing and security log. Okay, within the this you can also log something called as access transparency log, which captures whatever the action which are performed by a GCP on your content. Okay, this is very unique. What you can say feature which is not supported by all services. Yeah, it is only for organization with a gold support level and above. So these are the various levels of the supports. This will only come when you have a right mix of the support. Hmm. Cloud audit log answers who did what, when, where, and all those things, because it is going to give you all the details of the activities which are being done in your GCP account. Okay, so this is one of the examples you can see. Yeah, resource type, somebody has log name as this and log label as this. Uh, Type is what? So this is a kind of a data you will see. Okay, so let us look at this is a table which will help you to get more insights. Okay, for example, features. What are the activities it is going to log for admin? Okay, all API calls or other actions that modify the configuration of resource, it is logged. Then data access log. Okay, it is, yeah, it can do a reading configuration of resources. System event log, Google Cloud Administrator action, all those things. Then policy denied log, when a user or a service account is denied, that is also logged with your cloud this logs. So these are the various categories of the logs. Under that, this is what you are going to log. Whether it is default enabled, yes. Admin activity log is by default enabled. System event logs and then policy denied logs are also by default enabled. But data access is not there. Okay. Um, so what are the things which are logged in the admin activity? For example, VM creation, patching, resources, any change in the permission, and so on. In data access log, listing resources like what are the images available and so on is logged. Then system event logs, what it is going to do, what are the maintenance which are performed on that particular host. Okay, any automatic restart or anything which has happened. And then the policy denied logs, which will have a security policy violation log. Uh, yeah. Uh, then uh, so how are the logs captured for your cloud storage? With admin activity log, you can capture all the bucket or the object modify logs. Then you can the data access log will capture modify, read, object, okay, object or bucket logs, and nothing for the system and the policy. What are the recommended roles for using this the for this logs to be viewed? You need to have a viewer permission on the project and so on. So this is applicable for all of them. Okay, so we'll not look at this. Okay, we can create a centralized bucket where you can just log the things and all. We will not look at this. So you can also export these logs for any compliance audit and all those things. You can stay store it in the storage, cloud storage, BigQuery, and so on. This debugger. Okay, this is also very useful, but yeah, you can trace latency from your whatever the Google service, and you can find out how long does it take for your service to take handle, what is the average latency, how you are doing over a period of time, whether the latency is increasing or not, and so on. Okay, that can be done by using a cloud trace. And supported engines are this. Okay, so that's it. I would say let me look at other services which are pending, and then we'll continue that. Otherwise, I will open the Q&A and we will look at. Okay. Okay. Not really. Okay. Okay. Fine. So what I will just do, I will just explain you hierarchy, which is yeah. How do you organize your resources within the GCP? Because this is helpful when you have multiple accounts and all those things. That will help you to understand things. And then we will conclude our GCP section. Yeah. Okay, so this is the hierarchy of your GCP account. Whenever you create your account, you are getting like yeah. So you have to create something called as project. Okay, but the hierarchy is something like this. Yeah, domain which is at the cloud level. Then this is the organization, and then the organization in this you are going to create various projects. Okay, Now, whatever the billing which is going to happen, that is going to happen at the organization level, and you'll be able to see the bills there. Hmm. So if you, yeah, so what is recommended for a large organization? Yeah, yeah. So you should always create a separate project for separate different environment. For example, if you have a dev environment, you have a test environment, and so on. So you create separate project. By doing this, you can create a complete isolation from between your environment. Okay. Create separate folder for each department. So this is kind of a like it's kind of an organization unit. Okay. So you isolate production application of one department from another. You can create shared folder for shared resources. So it's kind of a organization unit. Okay. And you should have one project per application per environment. Okay. So it is something like that you have two apps and they are part of, let's say, two environment. Then in the ideal situation, you should create four projects, that A1 dev, A1 prod, A2 dev, and A2 prod. Okay. By doing this, again, the same principles, it is going to provide you isolation. It is going to separate out your environment from each other. Okay. So these are the best practices. These are followed when you have a very huge environment which has multiple account in it, and then you need to have such kind of a segregation. Then let's talk about the billing account. Okay, so billing, yeah, billing account is mandatory for creating resources in a project. So yeah, billing account will contain all the payment details. Every project with the active resource should be associated with a billing account. Billing account that can be associated with one or more. Okay, if you have multiple billing accounts in our organization, then yeah, so it is recommended that you create a billing account representing your own organization structure. A startup can have just one billing account, but larger organization can have separate billing based upon each department. Hmm. Okay. There are two types of billing account. One is called a self-serve, which is billed directly to your credit card or your bank account, and then one is called as invoice, which generates an invoice, and then that can be sent to the organization, generally, which is used for large enterprise and so on. So in this case, we as an individual will be a self-serve one. Hmm. Then managing billing budgets, alerts, and export. You can set a billing budget, which will help you to alert in case there is any kind of a breach in terms of the budget. For example, if you reach a 50%, a 90%, 100%, then yes, you should get a bill. You can also export your billing data. You can schedule it. If you want, you can do it, send it to the BigQuery, or you can also send it to your cloud storage for longer period of time. Okay, so that's it what I want to cover as part of GCP. So if you have any questions, I am ready to take, or otherwise I will take one more topic, which is a kind of a refresher of all the three cloud providers in terms of their comparison, and then we will conclude today's call. Yeah, anyone has any yeah, any questions? Hmm? Yes, no? Yeah, no? Very good. Either you have understood completely or you did not understand. Okay, but that's fine. Okay. So let me move to another topic, and this is more from giving you a perspective of what you can expect and how do you look after one service in comparison with other service from a particular service provider. So we'll look at that as well. Yeah, how do I limit billing on cloud? Okay, so if you want to limit the bill in any service provider, continuous monitoring and continuous review check of your resources is needed. Hmm? A few of the methods how you can save the cost is to start small, and then based upon the utilization of your resources, increase the capacity. Second way is when you know that you need a certain amount of capacity, try to use a kind of a, um, a reserved or you committed instance. Yeah, and that way you are going to pay less. Okay, look for options where you can use sustained virtual machines, or for example spot virtual machines, which will help you to, okay, yeah, to get a huge amount of discount on those. So these are the ways you can do that. And actually it is more of a, I would say, not a one time thing, but it is a very very continuous. If you don't pay attention to your costing on your cloud environment, then it can spiral into a big bill. Okay, that is the same principle if you, whether you go to AWS, whether you go to Azure, whether you go to GC. It's the same principle which is there. Hmm. So uh, not this one. Um, yeah, okay. Yeah, I hope you are able to see this. Yeah, I have, yeah, I'm trying to use this PPT. Okay, so what you can say, any service provider will have certain key pillars of their cloud services. Yeah, some of the pillars which is available in all the service providers, like availability, resiliency, security, yeah, scalability, all those things, and all the services are actually depending on all those things. Yeah, so if you look at your AWS, okay, it has lot many services. The advantage you get with your AWS is it has a maturity, yeah, of the products. The services are very very matured. They does not look disjointed, and you have a huge amount of services. Close to around 275 services are available there, and they are tailor made for your specific needs. Okay. So again, we have already seen the concept of region availability, which is there. At this point of time, AWS is the service provider which has a huge global infrastructure setup, which is, as compared to your any other service provider, it is the largest one. Hmm? In terms of the growth of service provider or a market share, AWS is leading, followed by your Microsoft and then the Google. Hmm? But yeah, all of them are actually leading. And if you look at the Gartner's Magic Quadrant report, um, you will see the AWS is placed in the leaders quadrant, which is where everybody wants to be. And if you are at the top right hand corner, then you are the leader in that. So AWS as such is sitting at the top, okay, and the other service providers, they are trying to do a catch up. Your Google is actually trying to catch up and go into the leaders quadrant, which is, I think it is not being, yeah, but yes, Microsoft is already there and it is trying to catch up. So this gives somebody, any the CXO level leader, understanding how the various cloud provider are faring in terms of the market share. Yeah. When we look at the security and compliance posture of AWS, there are various services and they are actually compliant with all the leading standard compliance certification. For example, ISO 20001, okay, then PCI, yeah, SOC compliance, PCI data, all those things, they are compliant with a lot of the uh, certification. In terms of the security, you have various services like CloudTrail, which is going to give you audit of all the activities which is done in your AWS account. Trusted advisor, this is one of the service which is a kind of a advisory services which gives you advice or based upon the five components, for example security, costing, cost, resource utilization, efficiency and reliability. Again, this comes with your support plan. Yeah, you need to go and check your support plan to get all the features. Then you look at some kind of a enterprise support from your AWS environment. Okay, if you go for enterprise support, that comes with a technical account manager, which will help you to coordinate any service issues with the AWS. Then for any kind of a data encryption, you have a service called a KMS, which is a key management system. You can use this KMS to do the data in transit encryption. Then we also have something called as Cloud HSM. This is for a kind of a, what you can say, a multi-factor authentication device, which is based upon the actual physical hardware, which is which is compliance with the FIPS, or the FIPS FIPS 3 regulation of the US federal government, and it complies with that, and it is available with your AWS cloud. Then you have a huge amount of the images which are available with your AWS marketplace. So many varied partners, which are bringing their images to the AWS marketplace, and that can be consumed by the consumers of the AWS. Hmm. All of them has a flexible licensing model. You can bring your own license to the cloud. You can pay per use. You can use any kind of a service provider and so on, which is available with your within the marketplace. Then your the AWS cloud, it supports lot of languages, different language, for example .NET, Go, Cloud Shell, Java, Python, Node.js, so on. Okay, then you will see all these services are they are tightly coupled with various other services. For example, Lambda. Okay, Lambda is nothing but a function service. We have seen the Azure function as well as your GCP function. Lambda is one of the service which is again which supports all those things. Then we have various other services which can be triggered by using the Lambda functions. Then a database, we have a huge amount of choice in AWS. You have RDS, which supports 6 database engines. You have non-relational database. You have a GraphQL, graph database, which is Amazon Neptune, then in-memory, then data warehousing solution. You also have a complete data migration or a database migration solution in form of DMS, data migration service, which is very useful when you want to do homogeneous as well as heterogeneous migration of your data. That is also possible. Then you have huge amount of virtual machines or EC2 instance which are available, which can be categorized into different families. For example, bus table, general purpose, compute optimized, memory optimized, storage optimized, and accelerated. Hmm. So you can go from a very small to a huge, which provides you almost 12 terabytes of RAM. Hmm. Then you have network segregation by using the VPCs. You use various components of your VPC, like your VPC peering, VPC connection, and NAT gateways, private gateways, and so on. Okay, so that helps you to do segregation of your resources. You use direct connect, which is kind of a dedicated connectivity between your on-premise and your AWS environment. That is also there. So every service provider has this kind of a there is a dedicated connectivity. Then certain services like SQS, SNS, Kinesis, Firehose, these are very good services which are catering to the modern application. For example, if you want to ingest a huge amount of data and then process that in a real time, then you can go for a Kinesis Firehose. Kinesis Stream, Kinesis Firehose. Those are the services which are very useful for streaming or ingesting streaming data. Then for any kind of a notification, you have SNS, SES. Any kind of a decoupling of your messaging, you can use the SQS. Then, okay, your the AWS environment can be built using various tools which are available, be it from the AWS native tools like your CloudFormation, AWS CDK. or you can also use third-party tools like Terraform, yeah, Ansible, Chef, Puppet, which are configuration management tools. So you have a lot of choice in terms of creating your infrastructure by using using the infrastructure as a code tools. Okay. Few of the advantage I would say, the there is a huge amount of resources which are available when you want to go and start using your AWS environment. Yeah, so there are a lot of trainings. There's a free tier account. There's certification courses, and then there are programs like AWS Academy, Educate, and so on, which help you to do a faster onboarding on the AWS platform. And then you can start working with that. Okay, what are the good and the bad? Good is capabilities are capability to build anything because the services are very mature, very easy to automated, and AWS is constantly innovating, bringing more new services. Again, it is language OS agnostic, having a huge user base, and then also very good support from the AWS. What are the bad? I would say very okay. Um, yeah. Um, you need to keep a tab of the cost. If you are not keeping a tab of a cost, then yes, it can go and give you a very huge your bill. Yeah. Um, so some of the offerings which are there in the AI and ML spaces, they are not as good as they are with other service providers. Then use of the AWS users, server roles, and all those things at times can be complicated. Okay, so these are the various good and bad about the service provider. Then let us go onto Azure. Azure is also being used by a lot of customers, a lot of big names, and so on. They also have a very huge presence in terms of the global infrastructure. In India also, they have a very good presence. Okay, various other services which are comparable services which are as compared to AWS they are offering. Yeah, again, lot of things which you can do, more focus towards the virtual machine environment, and then slowly picking up on the container services as well. Hmm? With your the compute services, you can have lot many variant in terms of the virtual machines which are offered. You can have various series of virtual machines. Yeah, you can have a deep learning virtual machine, and you can have some kind of a special what you can say hardware GPU based kind of a virtual machines. Then it also have a very good amount of data lake solutions, Databricks solutions. Yeah, for example, Azure Databricks, Azure HD side, and data analytics. So which is very useful when you want to play with any kind of a big data solutions. Yeah. Okay. Then you can categorize all the data storage and analytics service in different categories. For example, you have all services which are related to the AI machine learning, where you need to do a lot of analytics processing. Yeah, all those things can be categorized here. You have a very good offering on the database side for in terms of SQL database, data warehousing, data lake solutions. Yeah, and then you also have various services which are like IoT Hub, IoT Grid, sorry, and Event Hub, Event Grid, data cataloging, that is also available with your Azure. Then in terms of analytics, yes, we have just seen this machine analytics and all those things. Networking also, which is very key or a backbone of any services, is also available. You have various tools built into the Azure environment. For example, you have the dedicated connectivity via using something called as Express Route. You also have a VPN connectivity. Then within the VNet, which is your virtual network, you have various components like load balancer, traffic manager, yeah, VPGs, NSGs, and so on, which is helpful to have a very secure environment. Hmm. Then one thing I would say, it is having a very good ecosystem of the DevOps tools. Yeah, you can do lot many things with the DevOps tools which are available with Azure. It gives you a lot of flexibility in terms of adopting various other tools which is not available with actually AWS. Yeah, so yes, if you look at my personal opinion, Azure DevOps is far better as compared to the features and everything in comparison to your AWS. Then there are a lot many things from the AI and the machine learning. Lot of ready-made built-in solutions where you can use those and start working on your machine learning models. Advanced analytics is also very crucial. So you have various data processing like data lake, data breaks, then model training services like Azure ML. Then you have for model training, you can use containerized service and so on. DevOps, yes, DevOps is very good. Yeah. Security compliance, there is a heavy reliance on the Active Directory concept. Whenever you are using your Azure environment, you need to get familiar with the Active Directory to learn and understand how the permissions, roles, and policies will flow within the environment. Hmm. Um, Security can be built in by using RBAC control, okay, role-based access controls. Then a lot of services to do the monitoring, like Azure Monitor, Log Analytics, and so on. It is also compliant with a lot of industry standard regulation, compliance certification, and so on. Yeah. So what are the key differentiators? I would say, yeah, more. I would say they are focusing more on the PaaS services rather than the infrastructure as service. Integration, it is easier to integration, I would say, but yes, I find it very difficult. Uh, then what are the goods and the bad? Yeah. Uh, True trusted enterprise, because yes, Microsoft is the parent company, and this is being used by almost all the top organization in the world. Okay, it has a dominance in the PaaS offerings. It is actually moving towards a very mature services. Then again, very good support. Yeah. um, you can see that, yeah, there is a clear consideration for anything which is on the .NET. So yes, um, whatever the solutions which are available in .NET, yeah, you can easily migrate to the Azure environment. Hmm. Negative, looking at the market position, whatever the maturity which is there in the environment, it is still not at the acceptable level, I would say. Then any kind of a cross-platform integration is missing. Um, yeah, there are certain free services, there are certain services which are preview, and yes, but then again, that actually is at times not good for customers who want to adapt and then start working with those services. So yes, some negative points are there, but then yeah, again, it is very subjective, and those can be worked on. Then let us go to the GCP. Yeah, so GCP is more, I would say, a developer centric kind of a solutions, wherein you work everything based upon the APIs. Yeah, and this is more focused on the maybe on the container side of the things. Yeah, and wherein whenever you want to work with any service, you just go and use the APIs for it and start onboarding all the things. So these are the various, I would say, the services. For example, compute, data, big data, identity and security, and then the AI as well. So there are a lot many services which are available. Okay, developer tools. There is so many developers tools. That's why I was saying it is very developer friendly. Yeah, I would say very limited presence across the globe. Yeah, but it is still trying to do a catch up. Yeah, um, So yes, if you need to go for a particular service, please look out for that particular service before you want to start using it. Yeah. Again, network from a networking point of view, yes, a very well spread networking. Okay. Yes. So where is GCP going? Yeah. So what you can see is then this the magic quadrant is Google is trying to do a catch-up game. Yeah. Wherever. Um, so it is trying to do the catch-up game with the big boys, which is the AWS and the Azure. Yeah. But again, it needs a very huge push, and it is trying to come to that level. But it is again far away from the market leaders. GCP also offers you a free tier usage. There are certain services which are free of cost for 12 months, but then there are services which are always free. Hmm. Here are the things we have already seen. Hmm. Okay, from a machine learning and AI perspective, I would say the developer ready APIs are there, which you can just plug in and play and start working on it. Lot of models which are already built and you can consume those. Hmm. Yeah, a lot of offerings in terms of what you can say machine learning products which can be used to do build model and so on. So for example, there are teraflop, uh, yeah, the the platform, the cloud compute platform which are available, they are very excellent for doing the machine learning model build and all those things. Then databases, yeah, not much list, but yes, the their cloud spanner is a differentiator in terms of what you can say, um, which can do a horizontal scaling. That is a little differentiator as compared to other service provider. Yeah. Yes. So this is the best of the relational knowledge database, which is available with the cloud spanner. Again, a lot of focus on the serverless architecture by offering services like Google function, Cloud Function, App Engine, your Kubernetes engine, and then even the pubs of service. Okay. Then there is one more thing which is very evident from Google is it has a very tight integration with various open source service platforms. For example, STO, yeah, Kubernetes, CNCF Foundation, and so on. This whatever the Kubernetes, it can also be built onto your on-premise environment. You can very well work with it. What are the good and the bad? I would say good is like it is more focused on the developer, PaaS service, serverless, and so on. Yeah, there are huge amount of libraries which are there for machine learning, deep learning, and so on. Good serverless offering and still growing. Bad is I would say it is still doing a catch-up game, very limited coverage. Okay, and it is not yet at the maturity level. Okay, but yes, certain services are very good, and that is actually being helping Google platform to move up the ladder. So that's it what I want to cover. So if any questions, anybody, any questions on this? Hmm? Now somebody has asked me earlier which is the better cloud. Yeah, so it is again very case to case basis. If you look at the ease of operation, the maturity of the services, the breadth of the services, then anytime AWS is the leading. Now somebody who's using the Microsoft component from a long period of time, he might feel that yes, Microsoft is better. Again, it is a kind of a perception. Once you do a apple to apple comparison, this will clearly show you a result. So looking at the market share, I would say clearly AWS is leading in terms of the offerings, the innovation, and the number of services it is offering. But again, it is case to case. It needs to be handled on a case to case basis. And uh, yeah, so go and do a holistic view, not to compare that, yeah, this is good and this is bad. Do a case to case basis analysis and look for it. Hmm? Any questions? Yes, Sagar. Yeah, this PPT will be shared. Don't worry. It will be available in the LMS. Anybody? Any questions? Hmm? No? Okay. So if you don't have any questions, then we will wind up the session and we will meet tomorrow, or maybe if yeah, maybe we will meet maybe on Monday. Yeah. So that is not yet clear, but yes. Okay, so that is what I want to teach you, I would say, and that is what I want to pass on to you. I hope you liked it. And yeah, Amar, do we have a feedback as well for all the sessions? Hmm?
Yes, yes.
So is it like shared constantly, or it is at the end of the class, or how it is?
The feedback is collecting every day in attendance form itself.
Very good. Okay, okay,
Yes.
fine, no worries.
Sir, so tomorrow we are going to take a question answer session.
Yes, that is, yeah, means tomorrow most probably we might not have a class, but yes, I will confirm that. I will speak to Sunil and then we'll let you know.
Okay, sure.
Okay.
Student will be also ask us the question regarding to the LMS and everything material.
Yeah, yeah. So I will share the content yeah, tomorrow, and you can upload in the LMS.
Okay,
Okay.
okay, okay.
Sure.
Yes, done.
Okay. So thank you very much. Yeah, it was nice. Yeah, nice interacting with all of you. Yeah. So all the best for your future, and we'll see later on. Okay. Thank you very much. Bye bye. Thank you.